Good morning, students. Today I teach limit of the function. Okay, and function already completed. No, all of you know the function. Okay, what is function? Function is that is a relation between two variables. First, all of you know variable, all of you know constant. Okay, so if we write, see, f of x equal to x square minus 1 by x minus 1. Okay, so this is a function f of x equal to x square minus 1 by x minus 1. Look at here given function is undefined at x equal to 1. If we put x equal to 1, so this value will be forming 0 by 0. Okay, undetermined. Okay, so the form is 0 by 0. Form is 0 by 0. To omit the form of 0 by 0, so we have printed limit. Okay, see here, if we put x equal to suppose 1.001, see, very close to 1, this value very close to 1. So the given relation is f of 1.001 equal to 1.001 whole square minus 1 by 1.1 minus 1. So you can write here. So if a square minus b square plus b minus b, no? So here 1.001 plus 1, 1.001 minus 1 by here 1.001 minus 1. Okay, so you can cancel this part. Understood? Here, so this value will be 2.001. So we can write this value approximate to 1. Similar way, if we put x equal to, suppose x equal to 0.99, approximate value. See, so 0.999, then we will get f of 0. It will be, you put here a square minus b square, so 0 whole square minus 1 by 0 minus 1. So it will be 1. This one. This you can write to approximate value to this one 1.99. So you can write here approximate value to. See, if you put here, say direct value x equal to 1, we are not getting any real value. The form is 0 by 0. But if we put very close value to 1, say 1.001, so the difference between 1 and 1.001 is very, very small. Okay, very, very small. So we are getting one value which is close to 2. Similarly, if we put here, see, 0.999, very close to 1. So it is less than 1. This is greater than 1. So here we are getting 1.999. This also very close to 2. So you are getting this is all are real value. Okay, so this value we are not putting direct 1. If we write, see, suppose f of x plus 1 into x minus 1 by x minus 1. If x equal to 1, then it is not possible. Understood? We don't cut at x equal to 1 because the form is 0 by 0. Okay, that is why at x equal to 1 given function is undefined. But if we put very close value to 1, see 1.001 not equal to 1, 0.999 it is also not equal to 1. Okay, so this form, the value of this one or this one, we can write x tends to 1. X tends to 1, keep in mind. Okay, from right side, also from left side. So when you are writing x equal to 1.001, so you can say this will be x tends to 1 plus positive side of 1, and when we are writing x equal to 0.999 here, then we can write here x tends to 1 minus. Okay, so in general form we have to write, wait, say so general form limit, that is x tends to a means, okay, so this we can write x tends to a plus and x tends to a minus, you have to write. But from right hand side tends to a, the value of x, this is variable, this is constant. Okay, and from left side, okay, left side of a, this tends to the value of x, the value of x tends to a plus and value of x tends to a minus. Understood? So in general form we have to write limit of a function, that is limit x tends to a f of x. Okay, this form is known as limit of the function. A function is defined, suppose undefined, one value are taking, this is undefined. But if we take very closed value, either left side or right side, then we are getting a real value. So this value is known as limit of the function. Okay, see previous sum, suppose f of x taking x square minus 1 by x minus 1. So limit x tends to 1 f of x, if we take, so then we are getting real value. So look at here, so x tends to 1 f of x, so limit x tends to 1, put the value x square minus 1 x minus 1. Now we can cut, see x tends to 1 x plus 1 into x minus 1 by x minus 1. Okay, see here not 0 is coming, x tends to 1 is given. So that is why, means say 1.001 or 0.99. So if we put here, this is not 0 by 0 form, tends to 1, that's why you can cut now. Okay, see, so limit x tends to 1 x plus 1, you put value. This value is not undefined now. So this is the real value. If you put x equal to 1, or see x tends to 1, you put 1 plus 1. So limiting value is 2. Understood? Because x tends to 1, if we put suppose 1.001, so this value will be 2.001. Okay, so it will be approximate to 2. This value tends to 2. Similar way, if we put here 0.999, the value will be 1.999. Okay, so this also tends to 2. So this is the limiting value. Okay, there you can put only just 2, since the function is not undefined. Means x tends to 1, you have to write here though. Since x tends to 1, therefore x not equal to 1. That is why we are cancelling both the sides, both numerator and denominator. Understood? Okay. So limit, remember, limit of the function, limit x tends to a f of x is known as limit of a function. Now, so limit x tends to, see, limit x tends to a plus fx is called right hand limit. Keep in mind, right hand limit, RHL, right hand limit, and limit x tends to a minus f of x is called left hand limit. Okay, left hand limit. So it will be LHL. If both the limit exist and having a real value, then we can say limit x tends to a f of x is defined. When limit exists, x tends to a of f of x exists. So if right hand limit both exist, also left hand limit also exist, and both are equal. Suppose one limit exists, another is not exist, does not exist in the real value, then it is not, okay, limit does not exist. Suppose right hand exists, left hand not exist. Understood? Or left hand exists, right hand not exist. Suppose, see, I am writing one sum, then you can all of you understood. See, suppose limit x tends to 3 root under 3 minus x. See, this limit exists or not? It does not exist. See, if we put, suppose this one, limit x tends to 3 minus root 3 minus x. So you can write here 3 minus means less than 3. If less than 3 you put, this is defined value. Suppose 2.99 you put here. Okay. So in between root under, it will be positive. Understood? So it is exist. Suppose the value will be 0. Just we put the value 3, because this does not. This is defined value is there. If we put less than 3. But here limit x tends to 3 plus root 3 minus x. This is, see, does not exist. That is not belongs to real number. See, suppose 3 plus means you put 3 plus means 3.01. So look at here, 3 minus 3.01. So here root under minus 0.01. So root under negative, that is imaginary number. Okay, all of you know. Root under negative imaginary number. So here real value does not exist. So this limit does not exist. Understood? This limit does not exist. Similar way, see, suppose limit x tends to 0, 1 by x should be, so you can write here this one, when write limit x tends to 0 minus 1 by x. This is minus infinity. Okay, already discussed. Here limit x tends to 0 plus 1 by x. This will be plus infinity, keep in mind. It is not a number, keep in mind. Okay, so it represents, that is plus, like that. If you draw a line, this is plus infinity, positive side, so with 0, this is negative side, so minus infinity is there. Okay, see how you get this one. Suppose x, f of x, f of x means 1 by x. Suppose you put here x equal to 0.01. So this value will be 100. So 0.001. See, this is thousands now, 10 cube. Similarly, 0.0001 put 10 to the power 4. So you like that. This is very closed. No? Tends to 0. So if this is small, very small, okay. So this part 1 by x, it will be very large. This is very large numbers there, no? So it's like that. So this will be plus infinity there. Understood? Okay. X is very small, tends to 1. Here tends to 0, 0 plus. Okay. Suppose if we consider this positive value, so look at here 0, very closed that side. Here very closed also. 0 minus, 0 minus, 0 plus. Similarly, if x is negative, this also negative. Suppose negative value take. Suppose again, suppose x, f of x. Okay. Now take this negative value. So this will be minus 100. Here also take negative, minus, okay, 10 cube. So here suppose minus 0.01, minus 100, minus 0.001, minus 10 cubes. You know, this is very small like that, very small. This is minus. So limit x tends to 0, 1 by x. Okay, it will be no real value. 1 is plus infinity, 0 plus, 0 minus, minus infinity. Okay, see. Okay, now all of you know one thing, even function, odd function, very important theory is there. A function is said to be even. See, even function. So even function is there even function, keep in mind here f of minus x equal to f of x. F of minus x equal to f of x, then fx is called even function. Suppose f of x equal to write x square, then f of minus x whole square. So x square, so you can write f of x. Okay, and odd function, a function is said to be odd if f of minus x equal to minus f of x. Keep in mind. Suppose f of x equal to, suppose x cube. F of x equal to x cube. So f of minus x whole cube, that is minus x cube. Minus x cube. Okay. So here minus f of x. So this is odd function. Any function can be expressed as the sum of even function or odd function. Keep in mind, any function. Okay, any function can be, very important theory. So I am writing here, look at here. Suppose this is 3 marks question. Okay, any function can be expressed as the sum of even function and odd function. Okay, suppose f of x, we can write half of, see, f of x plus f of minus x plus half f of x minus f of minus x, you can write. Okay, first you put suppose this one, right? Suppose capital Fx and this part suppose gx. So f of x, right? F of x is there, half of f of x plus f of minus x. Now you put f of minus x, half f of minus x. So you will minus both plus, say f of x. See? So this we can write half of f of x plus f of minus x. So you put here this part. See? Fx, no? So right, it will be f of x. So you are getting f of minus x equal to f of x. Okay. So this is even function. Similar way, this is odd function we put here. Keep in mind, very important theory. So the derivative, later I will discuss, okay, not now. So next chapter is the differentiation. Any function, okay, any function that is derivative of even function is odd and the derivative of odd function is even, keep in mind. And few limit forms are there, just I am writing here, always remember this part, okay. Limit wait, see, so limit x tends to a, x to the power n minus a to the power n by x minus a. Okay, n belongs to here any rational number n here rational number. Okay, the value will be n a to the power n minus 1. Keep in mind, limit x tends to 0, sin x by x is 1. X is here radian. X measures in radian, not degree. If degree is there, so it will be converted into radian, pi by 180. Okay. So limit, and you know, most of the students know their mistakes are there. Suppose limit x tends to 0, sin, this is given by x. Don't write 1. So we convert it into radian. See, like that. So here limit x tends to 0, sine pi x by 180 by x. So x you can write here. So pi x by 180 into, right, pi by 180 you can write now. Okay, so now this value is 1. So total value will be pi by 180. This is the answer. So it will be sine x by x. Okay, so it will be 1. Keep in mind. Similar way, suppose limit x tends to 0, tan x by x also 1. Okay, don't write limit tan x tends to 0, cos x by x. This is not a formula. Okay, so here also limit x tends to 0 if inverse functions are there, sine inverse x. Okay, so this is inverse function. Keep in mind, sine inverse x by x always 1. Don't take this one. See, these are difference. For difference, sine inverse x not equal to sine x whole to the power minus 1. Don't take, these are for difference. This represents an angle. I will discuss later in the circle function. This is an angle. This is the all of 1 by sine x. So sine x all of you know. So sine x whole to the minus 1 means 1 by sine x. Okay. So and limit x tends to 0 e to the power x minus 1 by x equal to 1. E to the power is an exponential function. Similarly, limit x tends to 0 log 1 plus x by x also 1. Okay. Proof is not equal, just to remember this one. Okay. Now limit x tends to 0 a to the power x minus 1 by x equal to log e base a greater than 0 equal. Okay. All of you remember this formula. And multiple angle, sum multiple angle formula all of you remember. Go. Most of the sums depend upon here. Multiple angle or sum multiple angle formula. Understood? All of you remember. Multiple angle and sum multiple angle formula. Understood? Okay. Okay. Next class I will do application. Okay. All of you remember this formula. Okay. Bye. No more today.